Alrighty, let's take a look at this question. We have a couple equations and we notice the unknowns, there's actually two unknowns, m and n, are in the exponent. So always keep your eyes out looking for common bases. So 27 and 9, actually 1/9 on the other side, those could both be written as base 3. So that's what we want to do with that first equation. So 27 could be written as 3 cubed, and then we'd have the 2m minus n still on the outside exponent. Now 9 could be written as 3 squared, but we want to bring that to the numerator, so the exponent could go negative. So 1 over 9 is the same as 3 to the negative 2. Or if you want to do it in an extra step, you go 1 over 3 squared, and then we bring that power to the numerator, making the exponent negative. All right, so we're getting there. We just need to do exponent of an exponent on the left-hand side by multiplying those exponents. So we have 3 to the exponent of 6m minus 3n equals 3 to the negative 2. All right, now that we have one power on the left-hand side, one power on the right-hand side, they both have a common base of 3. That will mean that the exponents can equal each other. So now we let 6m minus 3n, the exponent on the left side, equals negative 2, the exponent on the right-hand side. Now we're kind of stuck at this point because there's two unknowns, so we can't really solve. So let's go to the other equation. All right, let's look at the bases here. We have 49 and we have 7. Those could both be written as 7. So 49 is going to become 7 squared. Still have the 3m minus 2n on the outside. And then 7, of course, is already a base of 7, but let's put an exponent of 1 on it just to emphasize that. Okay, so we do exponent of exponent again on the left-hand side there to get 7 to the 6m minus 4n, multiply your exponents, equal 7 to the 1. All right, now we have 1 power equals 1 power. The bases are both 7, so the exponents now equal 6m minus 4n equals 1. Okay, so what we've got now are two equations with two unknowns, m and n. And we can solve by elimination or substitution, but I think elimination would be better on this one because well, first of all, none of the coefficients are 1 or negative 1, so substitution would not work as well. There would be fractions. And I'm noticing that the coefficient of m is the same. So let's write this equation underneath this other one. And then what we're going to do is we're going to subtract that equation from the first one. So just got to remember when you're subtracting, though, we have to distribute that negative through. So 6m minus 6m, that will be gone, hence eliminating one variable. We have negative 4n minus negative 3n, meaning basically plus 3n. So negative 4n plus 3n would be negative 1n. And then on the right-hand side, we've got 1 minus a negative 2. So minus a negative would be plus. 1 plus 2 is 3. And then divide both sides by negative, and we get n would equal negative 3. Nice. Okay, we have n now. We just need to sub back into one of our equations to get m. Let's go back into this one. So we have 6m minus 3 times our n value we found, which is negative 3, equals negative 2. Simplify this. Negative 3 times negative 3 is positive 9 equals negative 2. Isolate m by subtracting 9 to the other side, and then finally divide by 6 to isolate m completely. So we'd have negative 11 over 6 is our m value. And there we go. N would equal negative 3. And let's get those in the right spots. And m would equal negative 11/6, making our answer equal to D. And there we go. I hope that helped.